Let's talk about scripting. But what do I really mean by scripting? This is just a general term to say that, well, we're writing scripts using Python to do something for us, to use the power of the machines to help us be more productive, more efficient. So this section is all about making our lives easier, understanding what the power of Python is, what we've learned up until now, and how we can use it to make our lives easier. We're going to learn about processing images really efficiently. We're going to learn about working with files like PDFs. We're going to learn how to send emails with Python, even text messages. We're going to build a Twitter bot. We're also going to build projects along the way to show you all the cool things we can do with Python. My favorite project that we're going to build is a super secure password checker to see if our passwords have ever been hacked. It's a really, really neat project. But the idea here is that with Python, using all these libraries and modules that have been built by the Python community, we can do so much. So it's going to be a really exciting section, and it's going to open up a whole world of possibilities. I'm only going to scratch the surface, but I guarantee you, by the end of it, you're going to be really, really excited and truly understand the power of Python. Let's get started. Let's talk about image processing. This is something that happens a lot, and a lot of companies process images or videos. What do I mean? Well, Instagram here, for example, you may have used this service. What you do is you upload your pictures and Instagram displays it to all your friends. But if I click on one of these pictures here, this image isn't actually the image that I uploaded to Instagram, because the image that I uploaded to Instagram was very large. It was probably around 5 megabytes. What Instagram does is it processes this image. Maybe it adds some cool filters for me to make it look nice, but it also crops this image and makes it small. So it's only a couple of hundred of kilobytes. Now, why would they do this? They do this because A, they make pictures look nicer, but also to save themselves a bit of money. If they uploaded all the pictures that they have from all their users, and each picture was a couple of megabytes, that's a lot of storage space for them to have to hold on to these pictures, because each of these pictures are on their servers. So they save a lot of money by compressing these images. The same thing happens on Udemy as well. You may have watched a course on something like Udemy and thought, man, these videos are a little bit blurry. I wish they were a little clearer. Well, Udemy does the same thing. They host all of these videos. And if they hosted the original version of the videos, such as the ones that I record, in the full format, well, that's going to cost them a lot of money. So they're able to save money by compressing these videos so that they're smaller versions, but also help out other students that maybe might watch these videos, then don't have a good internet connection to watch them in HD. So this is a very common problem. So we're going to learn all about that. Now, what are we going to use? The key thing is that internet is your friend. As a Python developer, you should be able to find these libraries by just doing a simple Google search, such as image processing Python. And we see over here a bunch of resources, like 10 Python image manipulation tools, or things like OpenCV, which we'll talk about. But I'll save you the hassle and tell you what we're going to use. We're going to use something called Pillow, which is a pretty standard library to use with Python when manipulating images. What we're going to do is actually install this Pillow library. And there's a couple of warnings here that we're going to get to in the next video. But ideally, all you're going to do is, well, you can just pip install Pillow. So let's do that. I have a folder here and a project that we're going to be working on, so ignore the right side here. But in here, all I'm going to do is say pip, and I want to make sure I'm using pip3. Again, this is something we've talked about. It's up to you. Make sure that we're using the latest version of pip. And then say install Pillow. And in my case, it's already installed. For you, it may take a little bit longer to install this package. Now, in the next video, I'm going to talk a little bit about this warning, which actually leads us to a key developer fundamental. So I'll see you in that one. Let's talk about a key developer fundamentals. We haven't seen one in a while, so I hope you're excited to see another one. What is it? This one is pick the right library. What do I mean by this? Well, let's have a look at what we just installed in the previous video. We installed this library called Pillow, which allows us to manipulate images using Python. But I also mentioned that there's a couple of warnings here. It says, hey, Pillow and Pill cannot coexist in the same environment. Before installing Pillow, please uninstall Pill. We also have some version warnings as well. So what does this mean? Well, if I go back to the main page over here, we see that Pillow is the friendly Pill fork by this person, and Pill is the Python image library. What does this all mean? When you pick a library that you want to use, and trust me, you're going to do a lot of that in your career, you want to make sure that you pick either the latest, most modern library, but also the library that the most people use. And we've mentioned this before when using PyPy, right? We want to make sure that the library we use has a lot of community support. It's constantly being updated so that there's no security issues, or it's not a library that's not very well, because anybody can publish a library. When you look at Python image library, which is the original one that we used to have, and this is a Wikipedia article that I can link to. And again, this is something that you'll just have to learn to develop, the skill of finding the right library. So in here, we actually see that Python image library, so originally it was called Pill. And this library existed and was very popular. But when Python 3 came out, Pill didn't support this newer version of Python. So essentially what happened was it was forked. And forked simply means it was essentially copied because it was an open source library and developed into Pillow by another developer, which gives us Python 3 support. So that's what it means. It's a Pill fork that allows us to have Python 3 support. The key here being that, again, we want to make sure that we use libraries that are up to date, that work with Python 3, but also libraries like Pillow here that have a lot of community support. If I go to GitHub here, we see that it has 6,400 stars. It's been forked 1,200 times. And it's also used by 150,000 developers. That's a pretty good sign. We also see that the latest commit happened this year, which is awesome. Again, developing that skill to pick the right library is a sign of an experienced developer. So there you go. Another developer fundamentals. Let's get back to building some projects in the next video. All right, enough talk. Let's process some images and use our Python knowledge. Now, you might be thinking that image processing is something that you can do on your machine using something like Photoshop, even using a simple editing software. But where this tool really shines is when we have to process hundreds, thousands of images. You can do things really, really fast with Python. So let's get started with this. I've actually attached to this lesson a Pokédex for you. And this Pokédex has all these cute little Pokemons. We have Bulbasaur, we have Charmander, we have Pikachu, we have Squirtle. It's great. They're all extremely cute. And by the way, a little bonus just for taking this course. No other course is going to teach you this. Get ready for it. You ready? Bulbasaur, original name in Japanese is Fushigidane. Charmander? Well, Charmander is Hitokage. And then Pikachu, well, Pikachu is just Pikachu. And then Squirtle is Zenigame. There you go. Free Japanese lesson bonus for this Python course. Yes, this is that good of a course. All right, let's get back to some serious stuff. We have these images. Let's see what we can do with them. I'm going to have an image.py file, so you can just create this on your own. And I'm using Sublime Text here in my command prompt, but you can use whatever you want. And what I'm about to show you is something that, remember, you can always reference in the official documentation. When learning a library, there's nothing better than the official documentation, right? And we see over here that the first thing we need to do is to actually import the module just like this. So let's go back here and say from pil import image. So now we can do something pretty exciting. The first thing we can do is say image equals image that we've imported and just simply say open. Now in here, we just give it a file path that we want to open. In our case, let's open up Pikachu.jpg. So I'm going to say /, which means current directory. And remember, we're in the image playground directory. And I want to go inside of the Pokedex folder. So I'm going to say Pokedex and say /Pikachu. Make sure I spell Pikachu right here. .jpg. And let's just print the image here to see what we get. I'm going to save and run this file. So I'm going to say Python 3 and run the image.py file. Images.py file, because that's the name. There you go. We get an object here. You see, it's a pil object. It's a JPEG image plugin, JPEG image file, and it tells me exactly what it is. So we've converted or opened up this JPEG into an image object that Pillow gives us that we can now manipulate. So what can we do here? Well, first, let's just see the image.format. And this property is going to say, hey, what is image format? Image format, it's a JPEG because, well, it's a JPEG. That's awesome. So we get different properties here. What about size? Can you tell us about the size? Well, yep, the size of the image is 640 by 640. Awesome. That's good. We get some information. What if we do mode here? What does mode do? Let's see. We see that the coloring is in RGB. So that's red, green, blue. All right, awesome. Let's clear the console here. There you go. Now remember, we're able to figure out what kind of functions, methods, properties, and attributes this image has by doing the dir command, right? So if I just remove this and do dir over the image, we get, well, all the things that this image has given to us. And again, this is something that we can check on the documentation websites as well. Okay, but let's do something even more exciting. You know what I want to do? I want to be able to maybe add some filters, maybe blur things in here. Well, Pillow gives us this image filter that we can now filter the image with. So how can we use it? Well, we can now have a filtered image, and this filter image is going to equal the image that we've grabbed, and we're going to say .filter, and in here, give it the image filter with some options. So here we can do different things. Let's do blur here. So capital blur. So now it's going to apply a filter of blurring. So let's see what happens if I do this. I'm going to, instead of printing, I'm actually going to say image.save. And this is going to save the filtered image. So let's do filtered image.save. And give it, let's call it blur, comma, and then the extension that we want to save it in. Let's just do PNG here. We'll change it to a PNG file, like this. And if I run this, look at that. We have a new file, blur.png here. If I click on it, Pikachu is all blurred up. You can see the original image right here, and then the blurred image. How cool is that? So let's do that again. Let's do something else. Let's do maybe smooth. which is another filter that we can do. If I run this again, all right, we see that the image is now, well, you can't really tell, but it's smoother. That's a filter that usually works better with landscape images. We can also do something like sharpen, and again, you can read the documentation to see different filterings that we can do. But let's check this one out as well. We got the original and then the sharpened one. There you go, there's a bit of a notice. Pikachu is looking very, very sharp. Now, the reason that I've converted this into a PNG is because PNG supports these image filters. So you might get an error if you actually keep it as a JPEG. And you know what? While we're at it, let me show you another thing that we can do. So instead of this filter image, we can actually do something called convert. And this converts the image to different formats. So one of the formats that we can actually do is something called grayscale, which is with a capital L. So when I do convert like this image, and let's rename it to gray.png. If I run this, my gray.png, Pikachu is in black and white. So you can also convert images to different formats. So remember we had the RGB, red, green, blue format. There's different formats that you can convert images to, but this one looks pretty cool. We've just grayed out Pikachu. Now, this is just one picture that we've worked with. But the power, and what I'm going to show you in the upcoming videos, is how we can apply, let's say, a function like this to hundreds and thousands and millions of images if we want, and process them really fast. But for now, I think this is enough. You can experiment and try different converts and try different image filters on your own. And we're going to learn some more in the next video. Bye-bye. Let's learn a few more neat things that we can do with images. Now, here we learned that we're able to save images, we can convert them, we can add image filters to them, and we also learned that we can actually use the save method to give a new name to a file, and then also give it an extension with the second parameter. So we can convert from, let's say, a JPEG to a PNG file like this. Another neat thing that we can do is also actually do something called show. And this is just going to show us the image. Let me show you. Haha, get that pun? Let me show you. All right, there you go. We see that it's now opening up the file and showing me the grayed out black and white 1920s Pikachu. Awesome. We can also rotate our images. So I can say filtered image. And this image, I want to rotate. Let's say 90 degrees. And I'm actually going to move this above the save so that we can see the effects. If I run this and go to gray.png, and let's just assign this to a crooked variable. And this crooked variable, which stores the new image, is where we're going to save. So let's just, let's save that and run this. And if we now go to gray.png, look at that. We got a crooked Pikachu. And we can, again, do different things. Let's do 180. So we have upside down Pikachu. And there we go. We have upside down Pikachu. So that's great. We can rotate images. We can also resize the images. So let's just say resize here. And this is going to be called resize. And instead of rotate, what we'll say is we'll say resize. And we can say that this image, remember, it was 640 by 640. I'm going to resize it to 300 by 300. So a nice little thumbnail. If I run this, and you see that I get an error here. And what I actually should have done here is the resize accepts a tuple. So I have to add brackets around here. So if I run this again, let me clear and run this again. And we go to gray.png. Look at that. Pikachu is a lot smaller than he used to be. Pikachu is tiny now. So we got tiny, grayed out Pikachu. So that's great. I can resize images, which is really, really useful. Now, let's say I wanted to crop my Pikachu image. What can we do? Well, instead of me telling you, let's just find out. We can go to the documentation website and simply search for crop. And if we keep scrolling down, well, let's just do .crop to see if there's an actual function that we have. And let's go over here, and we see that we have a crop over here. So cutting, pasting, and merging images. Okay, so let me just zoom in so you can see it a little bit. We see exactly how it can work. We can just pick the pixel location of the 4 corners and crop an image. So let's just copy that and try it out. So we have the region. So let's just say region, or let's just remove this and crop the filtered image with the box like this. And if we save this region image and run our code, let's go to Pikachu, and look at that, just the face of Pikachu. He's so cute. All right. Let's pretend that I didn't make that voice. Let's keep going. So there we have it. We can even crop images. I mean, this is pretty basic stuff, but you see the power of image processing. Whatever you want to do, you're not going to know at the top of your head. Instead, you're going to go to the documentation and say, hey, I want to have a blurry, grayed out image. How can I do that? Well, you just search the documentation page and learn the commands, and you write your file. And that's the key, right? You're not going to know at the top of your head the entire library. When the need arises, you just read the documentation. That's what good developers do. All right, we've learned a lot, but we still have a few more things to learn. So let's take a break, and I'll see you in the next one. Bye-bye. Welcome back. I have a new problem for you. I'm using a website here called unsplash.com. It's an awesome website where you can actually download for free really good images. Maybe you want to have a new background for your website, maybe a new background for your desktop. Anyway, I found this spaceman image and I've downloaded it, and I'll link to this image as well. Or you can pick whatever image you want from unsplash.com. And you'll see here that this image is 3.8 megabytes. It's massive. And maybe I want to bring it down in size. Maybe do a 400 by 400 thumbnail that I can use for my profile picture, so people know that I'm an astronaut. How can we do that? Well, let's go back to our code. We have this astro.jpg image, and you can see over here, I'm scrolling through it. It's absolutely massive. Okay, so let's make this smaller. I'm going to, instead of Pokédex, say I want to grab the astro.jpg image. And we don't want to do any of this, so I'm going to remove that. And first of all, let's just print what the image size is, just so we're clear. So I'm going to run this, and we see that, yep, it's a pretty big image. So all I'm going to do is say new image is going to be image.resize. And again, a tuple that says 400 by 400. And we've seen this before, right? So now if I save this, let's say new image.save, and I'll call it thumbnail.jpg. If I save this and run this, all right, look at that. We have a thumbnail.jpg. That's actually great. Look at that. It's tiny compared to the massive one we had. But one thing that I don't know if you can notice is that because the image did not have the same width and height, what happened was it is actually a little bit compressed. So it lost its aspect ratio. The image looks kind of squished in. So how can we fix that? And this is a common problem with images, right? If we make things smaller and smaller, or we change the aspect ratio, let's say 400 by 200. So if I save this and go to the image, well, yeah, look at that. The image is all squished up. How can we fix it? Well, in this case, we can actually use a useful thumbnail method. So instead of saying resize, if you want to keep the aspect ratio, we can say thumbnail. And this thumbnail will be 400 by 200. So if I save and run this again, we'll get an error. A non-type object has no attribute save. And that is because thumbnail actually doesn't return a new image, it just modifies the current one. So in here, we can just say image.thumbnail, and then we'll say image.save. So if I run this, and we go back to thumbnail, look at that. We have a thumbnail, but it keeps the aspect ratio. So even though I said 400 by 200, it's going to try and do its best to keep that aspect ratio and maybe not give the exact output that I want. So let's just bring it back to 400 by 400, run it again, and there you go. We have our thumbnail and the astronaut is not squished. Very, very useful. So the thumbnail one is really, really useful. Maybe if you want to create a profile picture for Facebook or Instagram or any other social media platform that you might have. And it just gives a tuple of width and height, and this is the maximum value. So it's never going to go over 400 and 400, but thumbnail is going to automatically do anything within the range up to 400, but keeping the aspect ratio. So if I actually do here print image.size, and I run this, you'll see that that's exactly what happens. It's intelligently deciding what the best size for the image is. All right, let's take a break, and in the next video, we're going to do a fun little exercise. I'll see you in that one. Bye-bye. Welcome back. It's time to apply what we just learned and do an exercise and build our own project. Now, what is this project? This project is going to be a JPEG to PNG converter. You remember our Pokédex, right? Our Pokédex are all these cute little Pokemons, but they're all in JPEG format. Now, JPEG image file format, you can read up on it, but I prefer PNG. There's some benefits that PNG files have, especially for these type of images. So for example, if you're a web developer, these types of images with not a lot of color or just a few colors, you can see over here, blue, brown, white, they're actually better when you develop websites to use PNG. Again, that's beyond the scope of the course. You can read up on this on your own. But a JPEG to PNG converter is really, really useful. So how can we build it based on what we've learned? I'm going to get you started, and the rest I'm going to try and see if you can figure out on your own. So what I'm going to do first is create a new file in here. And I'm going to use the command line. I can use touch here because I'm using a Mac. If you're using Windows, this command is different. And that's something that we've already talked about before. You can also just manually on your computer, just say new file. So you can just right click and say new file, whatever you want. Well, I already did this, so instead of doing touch, I'll just create a new file. And what we'll call it is, I'm going to call it JPEG to PNG converter .py. There we go. Now, what do we want this to do? Well, we want a Python script that I can run that works like this. I want to be able to say Python 3 and then say JPEG to PNG converter.py, and then give it 2 arguments. The first argument is I wanted to give the folder name. So I'm going to say Pokédex. And we're going to add a slash here to show that this is a folder. So I want you to open the Pokédex folder, and then the second parameter is the new folder that I want to create. So let's just call it new. So this new folder doesn't exist, but I want to be able to create it. And by the way, if you're on a Windows, this slash will be the other one. It'll be the backslash, like this. But essentially what I want to do is run this command. It's going to look through all the images here and convert them into a JPEG and put them in a new folder called new. So let's build that script. And I'm going to get you started with a little hint. What we need to do is we need to be able to grab these arguments and also grab all these files. And from the previous sections, we should know how to do that. What I'm going to do is import the sys module and import the os module. And of course, from the pillow library, I'm going to import pill from image. It's import here. There you go. Now, the first step is to actually, using the sys module, grab the first and second argument. So remember, that's the Pokédex and the new folder. So that's the first thing we want to do. The second thing is to, well, based on whether this exists or not, to check if new exists or this folder exists, and if not, create it. Right? So if this doesn't exist, we have to create the folder so we can put the images in. And then finally, what we want to do here, and this is the tough part, we want to loop through this entire folder. So loop through Pokédex, and then we want to convert images to PNG. And then finally, we want to save them to the new folder. This is a tough one. It combines a lot of the things that we've learned up until now. You might not get it right away because it is a little tricky, so don't worry. In the next video, I'm going to show you how to solve this problem. But what you might want to learn is how to Google, first of all, how to use sys to grab the first and second argument, how to use the OS module to grab the path so that you can say, hey, I want these files in Pokédex and I want to write to this new file. So we're going to use the OS module for that. And then obviously we're going to use the pillow module to convert the images to PNG, something that we've seen before. This exercise is going to require a bit of Googling on your case, which is a good skill to develop. So in the next video, I'm going to show you how to do this. I'll see you in that one. Good luck. Bye-bye. Welcome back. How was it? Was it tough? I hope you don't hate me for making it a little bit tough, but it's going to be a good thing. And remember, if you didn't get it right away, that's not a big deal. This is how we learn. So let's make this a little bit bigger. There you go. And start off with our first step, which is to grab these two arguments that we're going to have to use. So how can we do this? Well, first thing we're going to do is, let's say, path, which is the first path of our images. Or let's just call it image folder. And this image folder is going to use sys.argv, which is the arguments. And remember, the argv is, this is the first one, which is the Python file. This is the second, and this is the third. The way programming works, we start with 0, then 1, then 2. So all we're going to say is argv1 here. And then for the second one, which is the output folder, it's going to be sys.argv2. So I always like testing what we've done because we want to make sure that our assumptions are correct. So let's just print image folder and output folder. And let's just run this file. All right, look at that. We get Pokédex and new. It looks like this is working. Awesome. So we did the first task. What about the second one? The second one is to check if this new folder exists. If not, we need to create it so we can use it in here to put images. So again, this sounds like an if statement. So I'm going to say if, and then check if the folder exists. So the way we can do that is using the OS module. Now there's also the pathlib module that you can use. It's completely up to you. Now with the OS, what we can do is say os.path.exists. And this is just going to check, hey, does this exist? So I'm going to say output folder, does this exist? So let's just see what the output of this is. So before I even do the if statement, again, I like testing my code. So I'm going to say if OS path exists. Or sorry, instead of if, we want print. Let's run this. And we get false. Why is it false? Because it doesn't exist. So in order for our if statement to work, we actually have to do this. We have to say if not, because we want to get the opposite, right? So if this doesn't exist, then we want to convert this to true so that we can do something within this block, which is to create the folder. So how can we do that? Once again, we use the OS module and we use the make dirs or make directory method, and we just give it the directory output folder. So again, let's test our code. And if I run this, look at that. We have the new folder. Awesome. And this way, if I run this code again, we see that we don't create another folder because, well, we're just checking this. And because this folder exists now, we're not going to duplicate and make another folder. Awesome. So step by step, we're making headway. And again, you may be asking yourself, hold on, Andre, I never learned about make dirs. How do I do that? And again, this is something that you just have to practice, where you look up what the module does and you Google around, and this is how you figure things out. Nobody has things memorized as a programmer. Don't hate me. I'm just helping you practice that muscle. All right, last part. Last part is to loop through the Pokédex, grab each image and convert it and save it to the new folder. So how can we do that? Well, we do a for loop and we'll say file name in, and then again, we'll use the os.list directory. And this is going to be the items in the directory. So with list dir, what we can do is just give it the image folder. And in here, we now have each of these file paths. Now in here, I can say image equals image.open. And what should we do here? Because remember, we're going to open this every time, right? And this file, JPEG to PNG, is outside of these folders. So we somehow need to open these images at the Pokédex. But remember, we want to use whatever the input is, because folder Pokédex might not be always the same. So instead of grabbing the Pokédex folder, we'll just simply use an F string. And within this F string, I'm going to say we want the image folder, which is going to give us the Pokédex slash. And the slash here, because we assume that the user is going to enter the slash, we don't have to include it in here. And then give another string, which will be the file name, which we grab from here. So we now open these images, each one of them, and then we can just convert them, right? So let's convert them by saying image.save. And once again, we're going to use an F string and do the same thing, but this time for the output folder. So I'm going to say output folder, give it the file name, and then comma, and then convert it to PNG. And just for fun, let's just say print all done to let us know that every time an image gets processed, we print all done. Now, we're going to try and run this code. There's actually a bug in this code that we're going to have to fix, but let's just see what happens. So I'm going to run this. And there we go. We have all done, all done, all done, all done. 4 images. And it looks like it worked, right? Let's have a look. If I go to the new folder here, it looks like these are still in JPEGs. That's strange. Why would that be? I thought we should be converting these, right? Well, what if within here the save will do a .png? So again, let's make this a little bit smaller. So we'll say save as .png in file format PNG. If I run this, all right, look at that. We now have the images, but we have .jpeg.png. What's going on here? Well, we have to clean our name, right? So what we need to do is when we grab the image open, we need to remove the .jpeg from that image so we can save it as a PNG. So how can we do that? And that's something that you may have had to Google, because there's actually a useful tool that we can use with the OS module that allows us to do this. So what we can do is we can say clean name, and we'll say os.path.split text. And what this is going to do is it's going to split the text for us. So let me show you. I'm going to say file name. And in here, I'm not going to save anything. I'm going to comment this out. And I just want to print clean name. So let's just see what split text does. I'm going to clear this and run again. Oh, and I have an extra T in here. It should be split text. So let's save that again. And look at that. It gives me a tuple that splits the text between the name and the extension. That's extremely useful. So we just need to keep this first part, and we don't care about this part. So we can just access the clean name by saying 0. So the first item in the tuple. So now, if I go back to this, and instead of file name, we use the clean name to save the image, this should work. So let me remove some of the comments here. And another thing I want to do is I want to remove all these images because we don't need them anymore. We ideally have just PNG images. So I'm going to actually remove this new folder. So let's say delete. Okay, you can delete it. There you go. I'm going to save. And let's see if this works now. Let's run our command. All done. If we go back, hey, check that out. All our images are now PNG. And you saw how fast that was. We just created our first JPEG to PNG converter. This file can now convert, as long as you give it a folder with, you can give it hundreds of images, thousands of images of JPEG, and it's going to convert them to PNG. If you want, you can even resize them. You can even add image filters to them. And we're able to do that all with a few lines of code of Python and some useful libraries. Very, very cool. Now we're just scratching the surface here, but you're starting to see the power of Python. We have a problem, and this problem can be solved with Python and its libraries. And by just doing a bit of Googling, a little trial and error, and debugging our code, we just made something that could potentially save us a lot of time instead of doing this manually. Good job if you've gotten this far. This is our first image processing project. I hope you're excited. There's still lots more to cover, but give yourself a pat on the back, and I'll see you in the next video. Bye-bye. You've just learned about image processing. And image processing is similar to video processing. They're both essentially analyzing a frame of an image and doing something with that data. So where do you go from here? Well, We can use libraries like Pillow, which are really great for simple images, or you can use something like OpenCV. And OpenCV is a very powerful library. As a matter of fact, OpenCV is used with machine learning, like self-driving car. You can see over here, somebody built an OpenCV Python neural network autonomous RC car. Yes, what we learned, although is just scratching the surface, leads us to learn about autonomous driving and machine learning. Now, we have a section on machine learning in this course, so we're going to dive deeper into that. But with this newfound knowledge, you can even explore libraries like OpenCV if you're interested in this topic to learn how to analyze images and how to maybe use machine learning to do exciting things in the field of AI. This I'm leaving up to you to explore on your own. Again, the beauty with Python is that you can go in so many directions throughout your career. But for now, we still have lots more to learn, so I'll see you in the next one. Bye-bye. Let's talk about PDFs. How do we process them? I mean, we've learned about working with files in our previous section with Python. And you can imagine that we can work with any files. We've learned about image processing, but we've also learned that we can just manipulate any text file, any PDF file, any CSV or Excel file. These are all just file types that we can process and work with in Python. In this section, we're going to talk about PDF and how this might work. And this knowledge of PDF will transfer to different file formats. Now, we're going to talk about Excel files and CSV files later on in the course when we get into machine learning. But for now, let's work with PDFs and see how we can use Python to make our lives easier. Now, I'm going to link to some PDF files that we have here that we're going to use in this section. We have a simple dummy PDF file. We have another PDF file that actually has 2 pages. And then we have a watermark PDF, which we're going to save for our final project in this section. But let's go back here. From what we've learned so far, what do you think our first step is? Well, our first step is to find a library that we can use with Python to process PDF files. And get ready. For this section, I have a really impressive website. Probably the best website you've seen, probably the cleanest, most modern website when it comes to the package that we're installing. We're installing something called pip3 install pypdf2. Now, there's a lot of packages that we can install when it comes to PDFs. This is the one that I recommend for the course. Now, while this is installing, in my case, it's already installed. Let me show you what their website documentation looks like. Get ready. It's pretty. Here it is. Wow, right? I don't know why, but for some reason, Python documentation websites are not the prettiest. I mean, this is all subjective, right? Some people like this, but it just doesn't get you excited about working with PDFs. This website does it. Anyway, you can see over here that it's actually not that big of a library. And you can click on the documentation and again, read through everything. But let's just learn the basics. So the first thing I'm going to do is import pypdf2. And what we're going to do is work with the first one, the dummy.pdf, which is just this PDF file that is one single page that says dummy PDF file. Nothing too exciting. Now, how can we open this file? We know this from previous lessons, right? We can use the with open command and we'll say dummy.pdf. And I can say it like this because we're in the same folder. I have a pdf.py file that I've created. So I'm just saying, hey, grab the dummy PDF from the same directory. And in here, let's for now just do read because I want to read the file. And then just say as file. And for now, print file to see what we get. I'm going to run this file by saying python3 pdf.py. Let's see what happens. All right, I get a text IO wrapper, name, dummy PDF. All right, it looks like it's working. Let's just explore this a little bit more. to see that it is indeed working. What we can do is actually use the PyPDF to read the file. So let's do this. We can say reader equals PyPDF and use the method PDF file reader. Again, it allows us to read this Python file. So let's just give it file in here. And then we'll just print reader, and we can ask for a number of pages. Again, this comes with the library. So let's run this and see what happens. All right, we get an error. It says PDF read warning. PDF file reader stream file object is not in binary mode. What does that mean? Well, remember, binary is ones and zeros, right? If I click on dummies, dummy.pdf, this is not the PDF we thought. This is how a PDF should look, but you see, depending on the program that you're running, it might not be able to read the PDF file. So what we need to do, and this is just a standard that you have to remember, is that we want to read the binary. So it's read and then binary. So what happens here is that this creates a file stream object. So it's going to convert the file object to binary mode so that the PyPDF2 file reader can read this binary file object. So now if I run this again, look at that. It's able to read it and it tells me that this has one page. If I do 2page.pdf and run this, we get 2 pages. Awesome. Let's clear this and go back to our dummy.pdf. I feel bad for naming this PDF dummy. I shouldn't be mean to this PDF. I'll work on my naming conventions next time. So just like we saw in the image processing, with PyPDF, we can do a lot of things to process this image. For example, I can do get page here. And if I do get page, let's say the first page, and I run this, we get the page object over here. Now it looks like gibberish here because, well, this is a special object that PyPDF creates. But if I do something like page 1, which will be the page 2 in this case, I get an error, an index error, saying list index out of range because the dummy PDF only has one page. We can also do different things like, let's, for example, rotate this image, and we'll rotate it 180 degrees. If I run this, this doesn't work. Now, why is this? It's because PyPDF2 uses the reader object, but it needs to know what to rotate. In our case, we actually have to get the page of the reader to rotate it. So we have to do something like reader.getPage, get the first page of our dummy PDF, and assign this to the page variable. So that now that we have the page object, remember, a page object and a reader object. If I now run this, well, I get page object has no attribute rotate. And I may have tricked you a little bit to prove a point here. Now, this rotate object sounds like something that it should have, but it's actually not the right name that we want. So how can we solve this? And this gets back to us reading the documentation. If I go back to the file reader and let's search rotate, or let's go back here, we see that we have the page object class, which we have, right? We have the page object. If I click over here, let's find rotate. And we have a few things. We have merge rotate page. We keep going. And all right, we have rotate clockwise, rotate counterclockwise, and the angle. So it looks like this is what we need. We don't actually have a rotate method. But you see here, this is how we figure out what the library does. We also have scale to, scale by if we wanted to. So let's just copy rotate clockwise, or let's do rotate counterclockwise. And we'll just do 90. If I save this and run, all right, we get back an object here. But this object is actually in memory. If I go back to my dummy, nothing has changed because we haven't really saved anything. This is all in my computer's memory. When this program stops running, well, it gets trashed. So let's update our dummy.pdf to actually write and rotate counterclockwise. How can we do that? Well, with another with keyword. So inside of with open, we're going to say with open, and we'll call this, let's say, crooked. I don't know if this is how you spell crooked, so let's go with tilt.pdf. And we're going to open this file, and we're going to write to this file in binary format. And we're going to say as file. And in here, we're going to write the file to this new file. But how can we do this? This library gives us something called a writer object. So we can create a writer variable. And this writer variable will use the py_pdf.pdf. Instead of file reader, we have a file writer. And this allows us to write the object in memory so that now I can say writer.write. And just to make the naming convention appropriate, let's say this is going to be the new file. So we'll say new file. So let's see if this works. I'm going to clear, and let's run this. All right, we have tilt.pdf. But we actually forgot to do one thing because we've just opened a writer object, but we're not actually writing any PDFs into it. Ideally, we get the rotated page and write inside of it, right? So what we can do is remove the print here. We've rotated the page. And with the writer object that we have now, we can say writer.add_page and give it the page that we've rotated. So now, if I run this one more time and go to tilt, well, again, we see gibberish here. But if we open this, look at that. Our PDF is rotated, just like that. Very, very cool. So that's great, but kind of useless, right? Who really rotates PDFs? That's really hard to read. But at least this shows you the ability for us to process PDFs. Let's work on something more exciting. In the next video, I want us to do something a little bit more useful than this. So let's take a break and I'll see you in the next one. Welcome back. It's time for us to do something more useful. And what I want to do is actually combine PDFs. So I have this dummy PDF, and then I also have this 2-page PDF. And maybe we have a scenario where we want to combine PDFs to form just one super PDF. How can we do that? Well, let's create a Python program. What I want to do is I want to be able to call Python3PDF and then give it some arguments. Maybe to be able to say dummy.pdf and then combining it with 2page.pdf. And you know what? Let's combine tilt.pdf as well. And we can just keep adding and adding and adding different PDFs and combining them. Wouldn't that be cool? Well, let's do that. The first thing I'm going to do is import the sys module so that we can get the arguments. So I'm going to say inputs is going to equal sys.argv. And I'm going to do a little trick here. I'm going to say 1 and then colon. And remember, this is going to grab all the arguments besides the first one, which is our Python file. But it's going to grab all of these into a list called inputs. So we can include as many PDFs as we want. From here, let's create a function just to have our code be clean. So I'm going to remove this and call a function PDF combiner. And this PDF combiner is going to take a PDF list, which is going to be our inputs. And what should we do here? The first thing I want to do is just make sure my code works. So I'm going to do a for loop and say PDF in PDF list. And we're just going to print the PDF. So again, just to test our code, let's see if this works. I'm going to run this code. Well, and we have to call our function. So let's say PDF combiner and just give it the inputs. So I'm going to run this. And there we go, our 3 PDFs. That's great. But we want to actually combine these. So the way to do this is we actually have a merger object with PyPDF. So this merger object, we can say PyPDF dot PDF file merger. So that gives us a merger object. And the cool thing is that this is going to be really simple. All we have to do here is within our loop, say merger dot append PDF. So this just tells us, hey, merge everything into this merger object, the PDFs that we're going to loop through. And at the end of the loop, this merger is going to have all these 3 PDFs. And all we need to do is say merger dot write and just write the new PDF as, well, let's call it super.pdf. So let's see if this works. I'm going to run. And did you see that? We now have a super PDF. If I open this, all right, we have the dummy PDF, and we see over here we have 4 pages. We have dummy PDF, we have the simple PDF file that has 2 pages, and we have our rotated dummy PDF file. How cool is that? And notice here that we didn't have to even do the with open as file and then actually write. We can just use the merger.write method to write our file. So we have a PDF combiner. If we're working on a book, for example, and maybe we have different people working on different chapters, I can just run it through this function now and combine my entire PDF into one. Very, very cool. Or at least I think it's cool. I hope you find this interesting as well. But you know what? Let's go even higher. In the next video, I want to do something that's actually, I think, quite useful. So let's take a break, and I'll see you in the next one. Welcome back. In this video, we're going to try a little exercise. And I actually want you to try this yourself. And in the next video, I'll show you the solution. Now, I've attached here a watermark PDF. You can see over here that it says draft. And it's just 1 page like this. Now, you'll find this in your resources. But I want to build a tool that's quite useful that watermarks all my files. So remember the super.pdf file we made in the last video that had 4 pages? Well, I want to watermark this, all of them. So instead of me doing manually, let's say we had thousands of pages. I want a program that can watermark my PDFs. Now, why would this be useful? Well, in Hollywood, this is actually a useful thing to be able to do. Let's say you're working on a TV show. Let's call it Lost. And you want to give the script, which is super secret because you don't want the audience to find out what happens in the show, to your cast members. And all these actors are going to get a draft of the script. But we don't want them to leak the script to the press so that everybody finds out about it, right? So usually big companies in Hollywood watermark their script with usually an actor's name. So if that actor leaks the script, well, they'll know that that person has their name on the script and they're the ones that leaked it. So this is actually a useful thing to know. So how can we do this? Well, this is your challenge, right? What we want to do is ideally use the water.pdf that I'll provide for you. I want to write this water.pdf on all the pages of super.pdf that we combined in the previous lesson. Or you can have your own PDF file. So using what we've learned up until now and the PyPDF2 library, let's see if we can give that a go. And in the next video, I'll show you how I did it. I'll see you in the next one. Bye-bye. All right, how was that? Hopefully you were able to figure it out. If not, don't worry, here's the solution. What I'm going to do here is just keep the PyPDF import and start from scratch. The first thing I want to do is I want to grab this super.pdf that we're going to process. So again, I'll just call it the template, and this template will be the PyPDF. We'll use the PDF file reader object, and I'll actually show you a little shortcut instead of just opening it the way we have been before. We can just inside of here say open, and then say super.pdf, which is what we're going to open, and then open it with the second parameter being read binary. Just like this. We're going to create a file reader. Now you can do it this way or the way that I've shown you before. This is just a cleaner syntax that I like using. Next, I also want to open up the watermark PDF. So I'm going to call it watermark. And again, we're going to use the same thing. So I'm going to say file reader. And instead of opening the super PDF, I'll open the watermark PDF. And then finally, I want to be able to write my output and combine these two. So I'm going to say output equals, and we'll say pypdf.pdf file writer to create our write object in memory. Now, from here, this is the tricky part. Ideally, we loop through the pages here of the template and add the watermark to it. Now, we are not going to know how many pages super.pdf has. I mean, we might want to change this program so that we use the command line here to give it a file. But ideally, we want to make a program that is flexible, and no matter how many pages the given PDF has, we can process it. So what I'm going to do is use a for loop here. And we can also create a function if we want. But for now, because this is going to be just one block of code, we can just keep it without a function. And I'm going to say for I in range, because we don't know how big this file is going to be. And what I'm going to say is template.get num pages. Get num pages is going to tell me how many pages the template has. Remember, we've also seen the way of saying num pages in a previous lesson. But we can just use get num pages, just to show you something different. So now it's going to get the number of pages, it's going to create a range object out of it, and we're going to loop through it. So if we have 5 pages, it's going to loop 5 times. Now in here, what we can do is have a page object. So we're going to say template get page at the index that we're at. So this is going to go through each time, and it's going to get the first page the first time around, the second page, the third page, the fourth page, so that we go through everything. And that's going to be our page object. Next, what we're going to do is say page.merge page. And this merge page is simply going to get the watermark.get page at index of 0. Because the watermark PDF only has that one page that has the watermark. So I'm going to merge onto that page the watermark. Now notice here that I didn't use the PDF file merger. And I'll show you why merge page works the way it does. when we finish the project. But you can use either one. The key here with merge page is that I like the PDF file merger, which combines the files one after another. Merge page actually, merges the page like we want with the watermark. Now, this is something that you would have had to read through the documentation if you tried the exercise on your own. Again, one of those things that you just have to practice that muscle. Finally, now that we have the page, we can say output, which is the PDF writer that we're going to have. Our output will be the add page, and we're going to add this page that we've merged. And now finally, what we can do in here is say with open, and we'll call this new PDF, let's call it watermarked output.pdf. We're going to say write binary. And we're going to call it as file. So that now if we do output.write and write this file, let's see what happens. I'm going to run my program. And there you go. No errors. Let's see if it worked. We see that we have a watermarked output now. Again, this is gibberish, but if we open this, check that out. We have our dummy PDF file. We have the draft over here on the second page, third page, and even the fourth page with the rotation. How cool is that? We just created a PDF watermarker. That was quite simple, right? Again, if this is confusing and you're saying, hey, Andre, I didn't get this. Am I a bad programmer? No, you're not. This is very library specific, right? You're never going to get asked this exact syntax in an interview. Instead, you read the documentation. You want to merge pages. So you Google something like merge page on the official documentation of a library, and you figure out, hey, merge page is right here. I can read what merge page does, and we see, oh yeah, merges the content streams of two pages into one. All right, that's what we need. So that's what we use. And you experiment, go back and forth until you have a working project. There you have it. You can now work in Hollywood. Congratulations. I'll see you in the next video. Bye-bye. It's time for another project. And this time, we're going to use Python to send emails. That's right, we can send emails with Python. Now, we'll explore why this might be useful later on, but I want to give you a heads up. Python has a built-in email module. And this module actually got updated with Python 3.6, so I'm going to show you the latest version. When you Google how to send emails with Python, you might see a lot of outdated ways to send emails. So just a heads up that you might see something different than what I'm about to show you. But as of recording this video, this is the latest way to send emails. Okay, so why might this be useful? Well, imagine you have a list of emails that you've collected and you want to launch a new startup. You want people to know about your startup, right? So we can create a program that sends emails to maybe hundreds, thousands of people at the same time, maybe a customized email with their name to promote our product. Now, we'll get into spamming and things like that later on, but you might be thinking to yourself, why do we need Python for this? For example, there are tools like MailChimp. That is a software subscription-based product that allows us to do this. We can collect emails and also send customized emails. And you're right, companies like MailChimp or MailerLite, or there's hundreds of them, allow us to send lots of emails to potential customers, to sales leads, in order to try and grow our business. But I want to show you how to do it with Python, because there are times that it might come in useful. So let's get to it. And I'm going to use this project as an occasion for us to learn a few built-in packages in Python. Now, the first one we're going to use is the SMTP lib. So SMTP lib module. And we're also going to say from email.messages import email message. And this should be email message. Again, this is the email module that comes built in to Python. And actually, I'll link over here where it shows you some of the legacy API. So that is the outdated way to use things. We're going to do the emails.messages way of sending emails. Now, the other one is SMTP. Now, SMTP is going to allow us to create what we call an SMTP server. Anytime you send emails to anybody, it needs to have a server that communicates the language of the email. And this is what SMTP is used for. For example, on websites, you might see HTTP or HTTPS as the protocol of communication between a browser and a server. In the same way, emails have their own protocol for communicating, and that's through SMTP. As a matter of fact, the acronym stands for Simple Mail Transfer Protocol. It's a protocol or a standard for emails to be sent from computer to computer. Gmail uses this, Hotmail uses this, pretty much most email clients. I'm going to link to some resource if you want to read more about SMTP, but the key thing is if we want to send an email, we need SMTP server. Now, from here, we're going to dive into how to send our first email. Before we get into that, and the next video, I want you to go ahead and create an email account if you don't have one. I'm going to use a dummy email account, a Gmail account that I just created, because what we're going to do is we're going to have to log into this using a password, our username, and actually send an email from this email account without actually using this browser. So go ahead and create a dummy Gmail account, or you can use your regular one if you want, but I like to keep my passwords just away from everything, and I don't really want to share my personal email password with you, so I'm going to use this one. All right, let's take a break and send our first email in the next video. Let's send our first email. Now, this requires a lot of configuration that, again, you'll just have to get used to. So if it looks overwhelming, don't worry. Once you have this basic setup, you can send any type of email you want. So the first thing we're going to do is I'm going to say email is going to equal this email message that I just imported, this email message class. And this is going to be our email object. From here, we can add to this object the from key, which will be, hey, who's this email from? This email is going to be from myself, from Andre Nagwe. Next is, who is this email going to be to? Well, this email is going to be to, well, let's say Andre at 0tomastery.io. So we want to send the email to this email address. And then the email subject line will say, what should we say? Let's create the worst spammy email possible. I think this will be funny. Let's say you won $1 million. There you go. That's a spammy subject line, that's for sure. So that's our subject. The next thing we're going to do is say email.setContent method, which essentially says what's the content of the email. In our case, let's just say I am a Python master. Now in here, we can actually set any type of content we want. We can do text, we can do HTML, we can do images. We're going to get to that a little bit later on. But for now, this is fine. There you go. That's our email object with the from, to, subject, and content. We have our email, but we need to send it, right? So what we need to do is to use this SMTP server to log in to our Gmail client. and then send that email from there. So all we're going to do is say with smtplib.smtp, and in here, we're going to say what is going to be our SMTP server. And the reason I got you to create a Gmail account is just so you can follow along, because this is going to be custom to whatever email client you're using. In our case, we want our host to be Gmail. So I'm going to say smtp.gmail.com. This is going to be our host. And then this SMTP is going to be running on port 587. Again, you don't have to know this exactly. If we go back to SMTP, you see over here that typically submit outgoing email to the mail server on port 587. Remember, SMTP is a protocol. It's a standard for machines to communicate with each other. By using port 587, it's just a standard way for SMTP server to be run. Like I said, this is one of those things that you can usually just Google around and copy and paste because it's going to be the same. If you have a different client than Gmail, then again, you can Google and see what type of host you need. In our case, let's continue here. We're going to say with this host as SMTP, because we're going to use this now. Let's make this a little bit bigger so you can see. And in here, this is the part that's going to look confusing, but again, it's just you do it once, and once you do it, you have an email server that you can use. I'm going to say smtp.ehlo. Kind of looks like hello, but it's not hello. This is actually part of the protocol of the SMTP, again, the agreement. It starts with a little hello message that, well, it's typed like this. You can actually Google why this method is like this and not actually says hello. It's actually a pretty funny story. So we have SMTP hello. So that's the initial, hey, this is a server, I'm awake, hello message. Next, we do the SMTP dot start TLS. And TLS is an encryption mechanism. So we want to connect securely to the server. And now this is the critical part. Up until this point, you might be confused as to what we're actually doing here. We're essentially, with this next line, we're going to connect to this email account, this Gmail account that I created, so that instead of me opening this page, hitting compose, and writing that email that we already wrote, I can do it from code. So what am I going to do? I'm going to say smtp.login, and I'm going to log in with my credentials. So the first one is going to be this dummy email that I created, which is 0tomastery1@gmail.com. And next is going to be the password that I used for this login. Again, this is something that, because I've created a dummy account, I don't mind sharing it with you. The password is hello ZTM, my old friend 1. So this way, I'm able to log in to this server. And guess what we're doing next? Well, next, we're going to say send message. And we're going to send, what are we going to send? This whole email that we've created. So let's do email. And just for fun at the end, we'll say print all good boss. There we go. Now, if we didn't make any errors, this should actually work. Let's give it a go. I'm going to say Python 3 and then run our email sender.py. I want to give you a warning here. If you've named your py file email.py, this actually might give you an error. So make sure you name it something other than email.py. Let's give it a go. There's a bit of a pause, and we have all good boss. There was a pause here because we had to connect to our server, log in to our account, and then send the email, and then all good boss. So it looks like this code worked. So let's test it out. I logged into this dummy account, and I sent an email to Andre@zerotomastery.io. Let's check that email account. And look at that. You won $1 million. I am a Python master from the email address of our dummy account. Now, I actually had to pull this out of the spam folder because it was marked as spam because, well, it definitely looks like spammy email. So that's awesome. We're just able to send an email through Python. How cool is that? In the next video, we're going to explore this a little bit more and make this a little bit more dynamic so we can customize it to each individual that we send email to. I'll see you in the next one. Bye-bye. Welcome back. We want to improve our program so that instead of just sending a generic email like this, I want to customize it to each individual. Imagine if we have a database of all these users, all their emails, as well as their first name. Ideally, we're able to customize the email to each specific person. So how can we do that? Well, we're going to use an HTML-based email. So we can send text emails, which just have text, like we've seen, or we can send something more dynamic, like HTML. Now, this isn't an HTML course, and it's something that we'll go into a little bit more in depth when we talk about web development. But in here, I have a very, very basic HTML document. And this HTML document just has a body where we want the content of our email to be. Now, in here, I wrote, "You just won so much money." And then with a $ name. You can write whatever you want in here, but I want you to pay attention to the $, because we're going to do something neat here. We're going to actually update this to reflect a variable, a Python variable that we can substitute and customize dynamically. Now, how are we going to do that? Well, if we go back to our email, I want to introduce you to two new packages, built-in packages in Python that we can use. One is called the template or string template. So from the string module, we can import template. And what this template does, if we go to the documentation, right here, we have a string.template class. And what we're allowed to do is, as you can see here, using the $, we can substitute variables inside of text. You can see over here, if we zoom in a little bit, we have a template object with who likes what, and we can substitute these $, D, with who. So who equals to Tim. We can do template who likes what equals to S, and then substitute who with Tim and what with Kang Pao. So this is going to be very, very useful. And this is what we're doing with index.html. We have a $ name, and ideally we're able to update this. But we have a problem here. This is it's an HTML file. It's an index.html file. So how can we read this, convert it to a template, and substitute it? Well, we have another module that we're going to import. And this is going to be called pathlib from path. Import path. So this pathlib and this path that we import is actually very similar to something we've seen before, which is os.path. So we could have also imported the operating system OS module and used the path method, because what it allows us to do is to access this index.html file. So this is what it's going to look like. We can have an HTML variable that equals path and then give it index.html because we're in the same folder. And this path now gives us access to index.html, and we can use the read text method on it to read it as a text, as a string. Now, I'm going to leave a resource as to why we want to use pathlib instead of os.path, mainly because we have this read text method. But there's a great article here, why you should be using pathlib versus the os path module, that I'll link to and you can read on your own. At the end of the day, though, both of these libraries will be useful, and there's no right or wrong, just pros and cons. So we have this string, but now we want to update so that the name variable will be something custom. So what we're going to do is wrap this in template. So it becomes a template object. That's it. So we have this HTML that is a template. And if you remember, once we have this template string, we can use the dot substitute to give it, well, what we want to substitute it with. So instead of setting content like this, instead, I'm going to change this and say, I want HTML dot substitute to equal name, which is, remember, the variable over here, to have it equal, let's go with Tintin. And by the way, this substitute can have multiple parameters. So we can do it with keyword arguments, or we can even do it as a dictionary like this. So we can say name will be Tintin, and then we can add multiple variables if this HTML file had multiple variables, multiple, maybe name, age, maybe a greeting, whatever we want. So let's leave it like that. Let's save here and see if this works. I'm going to send once again. And this time around, I want to actually send it to my Gmail account. So we'll actually blur this out so you don't see my personal email address. All right. All good, boss. It looks like we didn't get any errors. Now let's check my Gmail account. Hey, look at that. Under important and unread, mind you, for you, you might get it in your spam folder. I have an email from myself saying, hey, I just won $1,000. Oh, and the last thing we need to do when we substitute is we have to tell it, hey, this set content is going to be HTML. So the way we do that is in the second parameter, we say this is going to be HTML. So it's not text like it was before. It's going to be HTML, so parse it accordingly and set content accordingly. So if I save this and we run, looks like we didn't get any errors. That's good. And if we go back to the Gmail client, hey, looks like I have a message that I've won $1 million. That's really great. Mind you, for yourself, you might find this in your spam folder. So again, make sure you check your email. Otherwise, if I click on this, look at that. You just won so much money, Tintin. How cool is that? So just like that, we're able to programmatically send emails, customized emails. Now, there's many applications of this. Maybe anytime a customer buys a product from your company, you want to send them a personal email, a greeting, saying, hey, thanks for buying our product. Or maybe you want to get yourself a reminder where every morning you send yourself an email saying, hey, get up and tidy your bed. There are so many applications. This is the cool part about Python, right? You can do anything you want. The world is your oyster. So hopefully this was exciting because we have a lot more in the next video. Bye-bye. Hello! I'm super excited because this is my favorite project of the entire course. As a matter of fact, I wish I could just do this over and over. I'm telling you, this project is going to wow you. Now, it's one of these projects that initially it doesn't sound that exciting, but I've included it in our course because I guarantee you, you talk about this project to an employer and they're going to be impressed with your knowledge. It's an actual tool that I use day to day for security reasons. And I'm really excited for us to build this together. By the end of it, I promise you, you're going to be extremely happy with it. Okay, maybe I'm a little bit overly excited about this kind of stuff, but hey, who knows? Maybe you will too. What we're going to build is a password checker. But not just any silly, dumb password checker. This is legitimately going to be the most secure way for you to check if your password has ever been hacked. That's right. So what's going to happen is we're going to be able to type in our terminal Python 3, and then we'll have a check my pass.py file that we're going to write from scratch. And in here, when we run this program, we're going to be able to input any password that we have and check if it's ever been hacked. Now, we'll get into how this works and how we know a password has been hacked in the next video. But just to show you how this works, if I say, let's say hello as a password, let's say if hello has ever been hacked, maybe password 123, and then a super tough password like this. So it's going to be able to check as many passwords as we list here. And if I hit enter, it's actually going to check these passwords. And we can see that hello was actually found, what is this? 253,581 times. So it's been hacked that many times. So you definitely shouldn't use this password. Password 123, as we can guess, yeah, you shouldn't use that password. What about this one, this gibberish password? This password has actually never been found. So you should carry on and use this password. Over the next couple of videos, we're going to build this tool, a tool that you can actually use in real life to check if your password is secure. Now, how does this work? Let's explore that in the next video. Welcome back. How are we going to build this tool? How are we going to know what passwords have been hacked? And what does it really mean anyway? Well, passwords get leaked all the time. We've heard about data breaches, right? Facebook has been hacked with data breaches. Equifax, LinkedIn, Yahoo, all these big companies sometimes get their databases leaked. And essentially what happens sometimes is our usernames and passwords get leaked to the public. And hackers, what they do is they compile these lists of leaked usernames and passwords and essentially try to log into different services. So there are databases, or you can think of them as massive Excel files, of all emails and passwords that have ever been leaked throughout history. And there's actually a website created by somebody called Troy Hunt, who's a very famous security researcher. And it's called Have I Been Pawned? And what you can do here is you can actually enter your email address and say, let's go andy@gmail.com. Has this ever been leaked? Oh no, it looks like it's been pawned. So it looks like it's been pawned on 88 breached sites and found 27 pastes. What this means essentially is that this email has been part of a data breach. So maybe I used this email as my Facebook login. Well, when Facebook got hacked and some users maybe stole user information, well, this email was part of it. As a matter of fact, for 88 breaches. And if I go to passwords here, you can actually do the same thing about passwords. I can check my password, and you can see over here that it doesn't show, and I can click over here to see if it's been pawned. Now, I just enter some gibberish here, and it looks like, nope, no pawnage found. But why does this matter? Why do we care that emails and passwords have been leaked? Hackers use something called dictionary attacks. And a dictionary attack, well, kind of like a Python dictionary, uses a massive dictionary with the key and value of, let's say, a username and password, and just tries to log into websites using these massive lists of information. And if your username and password has ever been leaked, well, a hacker simply runs what's called a brute force attack, where it just loops through all these leaked usernames and passwords and tries to log in. So maybe going into Facebook and just looping through this massive list, eventually they're going to hit something and be able to log in. Now, here's the thing. This isn't a web development course. I mean, this course is about Python. And although we have a section on web development, what I can tell you is that most of the time, even though I trust this website, it uses something called HTTPS, which is encrypted, I or you should never really trust a website with your password. Yes, maybe a big website like Facebook, maybe Google, we trust. But ideally, you don't want to send your password like this over the internet. Because what's happening here as soon as I click this is that it's being transferred to a server somewhere in the world. It's traveling through the internet wires and somebody could intercept it. So there's actually a more secure way of doing this. And this is where we're going to build. This website actually gives us a password API for us to do this and check our passwords, but in a more secured way. Because sure, we might trust this website, but the best security is to trust no one, right? Now, what I'm about to show you and what we're going to do is actually a technique used by legitimate password managers like Keeper, 1Password, you might have heard of, Blur, Sticky Password. These are expensive password managers that keep your password secure, but we're going to build that ourselves because we're programmers. So in the next video, we're actually going to start coding a bit and learning about this passwords API. I'll see you in the next one. Bye-bye. All right, let's get to our first step of building our secure password checker. Now in here, I have a checkmypass.py file. You can do the same, and then I have my terminal right over here. What we want to do is initially import the requests module. If you haven't, well, then you can install the requests module. The request module is going to allow us to make a request. So remember, it's kind of like having a browser without, well, the actual browser. We can just manually request something as if we have a browser and we get some data back. So the way we can actually use the request module with the password API is that we can have the password API URL, which I'll just tell you what it is. It's https://api.pwnedpasswords.com. And then we give it a range / and in here, this is where we give it the password. So we can just do plus, and let's just for now do password 123. So that's the URL that we're going to use. Let's make this a little bit smaller, like that. Now in here, we're going to get a response by doing the requests.get, and let's just type this in and see what happens. If I save and run this program, and remember, we don't have the ability to type in the passwords yet, so let's just run the file. All right, so we get something, but it looks like an error. And that's because I did HTTPS. Silly me. But again, I want to show you that, yeah, right here, I'm able to read the errors, and it looks like it's an invalid schema, no connection adapter for, well, HTTPS. So if we run that again, all right, it looks like it worked, no errors, but let's print this out to see what we get. So print response, and I'm going to run this, and we got response 400. Now, a response or 400 is not good. Usually that means unauthorized or something's not right with the API. Now, these response codes are something we'll get into in the web development section of the course, but it just means that 400 is not good. We want a response of 200. 200 means okay. And the reason this happens is because this is not how the API actually works. You see here, we just gave it a password, but the way that this API works is it uses something called hashing. Now, what does that mean? I'm going to include a bonus lesson after this one so that you can learn a little bit more about hashing. But I have here this website that I'm going to link to, and let's make this a little bit bigger. Hopefully you can see. It's a SHA-1 hash generator. Now, hashing a password, it's something that you should always do. Let's say you're saving a user's password to a database. You should never store a user's password in what we call plaintext. That is exactly what the password is. Instead, we want to do something called hash it. That is, run it through a hashing algorithm to make it gibberish. So when I do password 123 here and I click generate and I scroll down, this is the hashed password. Notice here that as I change this password, this changes as well. But the key here, and this is something that we'll talk about in that bonus video, is that hashing is a one-way function. So there's many different hashing algorithms. There's MD5s, there's SHA-256. We're using SHA-1 because this is what this API is using. And SHA-1 essentially just hashes. It's an algorithm that is a function that does this gibberish output of password 123. But no matter how many times we generate password 123, it's always going to be the same hash. So this way we can actually check if somebody types a password and we already have the hashed version of a password in, let's say, a database, we can actually compare the hashed version of this password to the database hashed password. Again, don't get too confused here. Hopefully in that bonus video, we'll cover this a little bit more. But the key thing is that this API, because we want to be as secure as possible, is, well, we don't want to send over the wire our real password. Instead, we want to send this hashed version of our password. So if I copy this and put it over here, this is what we should be sending to the API. But here's the problem. This is still not super secure because anybody can come now and type in and keep guessing, and eventually hit on password 123 and see, oh, this hash is the exact same one as this hash. So they will know that this is our password. So this API uses a technique called K-anonymity. And this is actually a modern technique that big companies like Google, Facebook, Netflix, Amazon all use. K-anonymity allows somebody to receive information about us, yet still not know who we are. How does this work? By the way, this is actually a technique that is used a lot, especially now where using personal data for companies, it's frowned upon. So ideally, you don't want to give your personal information to companies. So some companies that care about security and privacy use this K-anonymity to track you, but still not know who you are. Now, the way this works is that we only give the first 5 characters of our hash password. So 1, 2, 3, 4, 5. So if I remove this, what this API is going to do is it has a list of all the passwords that have been leaked. However, all these passwords are hashed with the SHA-1 algorithm. So it's going to look in its database of all these passwords and pick all the hashed passwords that have the first 5 characters that match this. So this way, with a response, we're going to get all the passwords that are hashed that have this. So that on our end, when we receive that response, we can check the rest of the hash function. This way, this API is never going to know our full hash, and therefore never ever be able to guess our password. They'll just know that we have this tiny bit of a hash function that could match any hundreds of passwords. How cool is that? So if I actually save this and run, I get a response of 200. Awesome. All right, let's take a break, learn a little bit more about hashing, and see you in the next video. Bye-bye. What is a hash function? It's something that's used all across computer science. A hash function is simply a function that generates a value of fixed length for each input that it gets. All right, what does that mean? Well, I have here a MD5 hash generator. MD5 is the type of hash function, and there's many types. You might have heard of SHA-1, SHA-256, and many others. Using this hash function, let's see what happens if I do hello. You see that right away, MD5 hashes this string and turns it into this gibberish. That's what a hash function does. We give it an input, and the function generates some random pattern. Now, there's some key aspects of hash functions. First is that it's one way, in the sense that if I give somebody this, they have no idea what the input was. And it's practically impossible for me to have any clue as to what the input is. The second is that no matter how many times I put hello in there, it's going to be the same. But as soon as I change one thing, it's going to completely change the output. If I go back to hello and watch me just change to capital H, even a capital letter, so it starts with 5D4. If I do capital H, it's completely different again. And looking at this, we can at least say that, I don't know what this is useful for, but the one thing that I know is that no matter what, if I give it the same input, it's going to give me the same result, but I have no idea how to convert this back into hello. This is what we call idempotent or idempotent. There's different pronunciations. I'm not really sure which one's which, but it is a fancy way of saying that a function, given an input, always outputs the same output. Now, the one benefit and why we would want to use this in a data structure is that we get really fast data access. Because all I have to do to find grapes, or basket.grapes, is to pass grapes into something like an MD5 hash. It generates this number for me, and I immediately know where it is in my memory on our computer. But this doesn't look like an address, does it? Technically, a hash function that we use for hash tables is going to take grapes, generate some sort of gibberish, and then convert it to an index space or an address space that it has based on this number. You see, unlike arrays where we just had ordered indexes, with hash tables, all we need to do is give it a key and we know exactly where that item is in our memory. But you might be wondering, this black box hash function, doesn't it slow things down? Because every time we want to add a property and a value, grapes and 10,000, to a hash table, we have to run it through the hash function so we can decide where to put it in memory. And if you've noticed that, good job. That is a big factor. You don't want this to take a very long time because, well, every time you add a property to memory or retrieve a property to memory, because again, both times we're sending the key grapes into the hash function to find where to get it from. We need this to be really fast. And underneath the hood, remember, because hash tables exist in all languages, they're implemented with an optimum hashing function that's really fast. As a side note, hash functions like SHA-256 take a really long time to generate a hash. And it is an overly complex hashing function that is used a lot in places like cryptography, where you want this to take longer, but that is outside the scope of this course. If you're interested, I do recommend that you check out the differences between these two. To review, we have a key that is grapes. We send it through a hash function that is going to hash something really, really fast and then map whatever the hash came out to be into a memory address where we want to store our data, our grapes 10,000. And when it comes to hashing functions, you typically leave this to whatever framework or language you're using. And we usually assume a time complexity or big O notation of O1 because this happens really fast. All right, now that we understand what this black box does, let's talk a little bit more about hash tables, why they're useful, and why, in some cases, are better than arrays. Welcome back. We just learned about the password API and how this API allows us to trust no one. That is, we only trust ourselves, and we're only going to give the bits of information that we feel comfortable to the API so that it gives us a response with some data that we can then calculate on our own machines that are hypothetically more secure. So what we did here is that instead of giving the entire hash of our password, we just give a little bit of it, the first 5 characters. Now, they have close to 600 million passwords in their database. And the website now maybe just knows that we're part of several hundred people that have a similar starting hash, but they're never going to know our password. But with this response data, we can now check our full hash to see if the password has ever been pwned or has ever been hacked. So let's start writing our program. Because ideally, in this response, I now have maybe several hundred lists of these hashes that I can check against. Let's think about what we want to do. So ideally, we have, let's say, a function. And this function will be the request API data, which is what we've done here. So we'll move that down here once we're ready. And here, we'll give it the query characters. So that is, we're going to give it this hashed version of our password. So this is going to be a function that for now we'll just pass, but this is going to request our data and give us a response. Next, with this response, we actually want to check. So we can say that we want to check the pwned API check, and in here we'll give our password. That is our actual password. In our case, it'll be password123. And in here, we want to do some sort of a check. We want to say check password if it exists in API response from up here. So for now, we'll just pass that. So let's work on the first one. That is request API data. We've already done some of this over here, right? I'm actually going to move this code up here. Make sure we have the padding. Now in here, instead of this string, I'll actually give the query character that we'll call the function with so that it's dynamic. And again, we'll request a URL, we'll have the response, and in here we'll do a check. We'll say if response.status, because remember, we can check our response. If the status is 200, or in this case, let's say if the status is not equal to 200, in that case, let's just raise an error. So I'll say raise, we'll do a runtime error, and we'll say, well, let's use an F string, and we'll say error, fetching, and then we'll give it the status code. So that is response.status. Oh, and actually this is status code. So let's just do status code here. And then we'll just say check the API and try again. All right, so this should be our error if we make a mistake. Let's just test that out. I'm going to just, let's do an API that doesn't exist. So I just written some gibberish here. If I save and run this, well, I have to actually run this piece of code. So let's just do request API data, and the query character is going to be 1, 2, 3. And you know what? This is going to error out whether I do that or not. So let's just do this because it's not the hash version. And I actually get a Python error of type error. Can only concatenate string, not int. So we can just convert this to a string because remember, we're adding it to the URL here. Again, if we run this, all right, look at that. We've raised a runtime error. We have a runtime error, error fetching 400. Check the API and try again. All right, so this part is working. But in this case, if we don't have that error, let's just say that we will return the response. Again, we're just writing small, simple functions. In this case, we just want to request API data. So now we can use it throughout our code. Awesome. Now, this next part is a little tricky because we have to run our password through the SHA-1 algorithm. Luckily, Python has a built-in module for us to do this. So we can actually do import hash lib. As you can see, it's a built-in module. So you can read up more on it if you want. In our case, we're able to do SHA-1 hashing like we did on that website with this library. In here, what we're going to do is, first of all, I want to be able to hash my password. So let's remove the pass here and say SHA-1 password. And we can use the hash lib like this, hashlib.sha1, which is the hashing algorithm we want to use. And this is going to be a little tricky, but you can just read the documentation. I'll just show you how to do it. In our case, we can do password, and we want to encode in UTF-8, which is pretty standard. Actually, you know what? Let me show you what this does. So I'm going to say print, and I'll just do password encode UTF-8. So let's just do that for now. For now, I'm going to comment that out. So I'm going to call pwned API check, and we'll do 1, 2, 3. Let's clear this. I'm going to save and run this piece of code. All right, it's encoded. You see this little B over here in UTF-8. I'll actually show you what happens when we remove the encode after this. Next, when we use the hash lib SHA-1, so let me just copy this. If I just run this, I get a SHA-1 hash object. Now, after this, we can call .hex digest, like so. And if I run this, well, how can we check this? Well, we can go to hashlib and just simply search for hex digest. So in here, at any point, you can ask it for the digest of the concatenation of the data, blah, 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 hex digest. So that doesn't really explain anything for us. Let's just go to the next part and the next part, and there you go, hex digest. It returns a string object of double length containing only hexadecimal digits. This is just something that we need to do in order to convert this object into this hexadecimal string. The next part, in order to agree with the API, is to convert all of this to uppercase. So if I do upper here, and I save and run this again, everything is in uppercase, just like we saw when we looked at SHA-1. So this is just something that, again, you don't really need to know. You just have to, you can Google around and see how to actually use this. Now, let me show you what happens when we don't use UTF-8 encode. So if I just do it like this, and I run this, you see that I get an error. the Unicode objects must be encoded before hashing. So it actually gives you a nice error, and we can just encode it using UTF-8 like that. So this is just the standard. Again, nothing too crazy. You can read up on encoding and UTF-8 if you want on your own. The key here is that by the end of it, we have a SHA-1 password that we can send. So let me just copy all of this. Going to remove the print. And in here, we'll have our SHA-1 password. Awesome. So for now, let's just return this SHA-1 password. And if I run this, well, looks like our code is working. We're not printing anything, but hopefully we are getting this SHA-1 password. Now in the next video, I actually want to try and send this to our API and see what kind of response we get. Let's do that. Take a break. I'll see you in the next one.